Hello, this video will show you how to get the NEORV32 running on a Lattice ECP5U5MG85F evaluation board. We are going to use a specific fork of the NEORV32 RISC-V microprocessor, specifically one that is compatible with the ADA NEORV32 hardware abstraction layer. This is Mr. Olivier Henley's NEORV32 setups main fork. So go ahead and download a copy of it with zip. So you will also need to download these files. So this NEORV32, this specific fork. So go download zip, and also the NEORV32 HAL. The HAL is not necessary, but it's just good to have. So in your downloads folder, this is my setups folder which I just downloaded. Go ahead and extract it. NEORV32 setups main. Open it. Yeah. As you can see, this is the file structure. Here is NEORV32. It's empty. So what you'll do is go back to NEORV32, extract, copy it, contents, Control A, Control C. Yeah. Once you have filled the NEORV32 folder, go ahead and create a new folder labeled Lattice. In Lattice, let's create a new project folder. So let's call it ECP5 NEORV32 blank. So we need a few files to get it running. So firstly, go to this repo, again linked in the description, and here get the diamond TCL file. Let's download it. We'll also, and we'll use the part1 files for this video. So we'll need the constraints file, we'll need the NEORV32 template file, and we'll need the ECP5 minimal main top level. So this will be our actual top level file. Download the top level file first, download it, and also just we'll download this only. So yeah, this is the folder. So in downloads, copy these two files, Control C, Lattice ECP5 and paste this. Now it's assumed that you have Lattice running. So in my case, I have it on path. So I'll just say diamond. Or you can just go in the folder and call it using the bash script. But yeah, this is how I do it. Before we run the TCL script, it's necessary that the file structure is maintained, which is NEORV32 is exactly here relative to the Lattice folder. Otherwise, the script will fail. Alright. So going back to your TCL console, source, NEORV32 TCL. Run it. So see, it's throwing this error. It's okay. We can just select the file, the FPGA again. So ECP5UM5G. I'm using the 85,000 logic elements version. My package type is 381 industrial. Okay. This will automatically load in all of these files, and it will also create a constraint file. I'm sure why it did not. Look at this. Okay, I see. This is like the one became a problem. So yeah, we'll just add it manually because it happens. Yeah. These files, add existing file. Yeah, library. So the NEORV for this project and how the TCL file handles it, all the NEORV32 files and the actual top level file live in the NEORV32 library. And this is the basic setup. So the new ECP5 evaluation board has a 12 megahertz onboard clock, and we are going to expose 4 LEDs to the NEORV32 just as an example. Like it can be done like how to pass it. So this is how we are instantiating the NEORV32. And if we go back to hierarchy, this is it. Go to source definition. Yeah. This is the source definition. This is 64K. So we are using 64K for IMEM and DMEM, and so we'll just populate the constraints file. Open. So you can see it's empty. So we'll just go back to part 1, the constraints file, copy everything that's here, Control C. Yes. No errors. In process, we can just try generating a bit stream now. Yeah. So the problem here is you are using the default lattice synthesis engine, which fails for this project. I am unsure about the reason, but a easy workaround is we go to active implementation and we select a different synthesis tool. So we have access to Simplify Pro, which works. Now if you try generating a bit stream, that's it. We were able to generate a bit stream. So let's program our FPGA with the newly generated bit stream. So we'll start the programmer. It may take some time to open, and sometimes it won't. So here's let's say okay. Now it automatically selected our FPGA, but in case it doesn't, we can just navigate the file explorer here. Since we fortunately have it, let's just use it. The rest is to program the FPGA. So we'll use GTK term to interact with the FPGA. So this GTK term, this is the command again in the repo. Yeah. It will work surprisingly. You always have USB 2. Okay, this is bad. Okay, that was something funny. It's just my UART was not connected to my computer. It's alright, we'll program the board again just for escape. Press the reset button, and as you can see, we can see output from the NEORV32 bootloader. It has 64K of IMEM, 64K of DMEM. So this is my Lattice FPGA board. So you can see it's already uploaded. The bit stream's already been uploaded. This cable is necessary to get the 12 megahertz clock running. It's also used to program the board. I recommend it connect it directly to your PC, but we are also using these UART pins. You can find them on the data sheet, otherwise the board has them labeled well. So match them according to constraint sheet, and the UART can be connected to a USB hub. So for reset purposes, we are using this pin, and yeah, the LED blinking shows okay the NEORV32 is running. And this works. Bootloader, let's start. Thank you. So now we'll run an ADA demo program. So first go back to the NEORV32 setups file, setups repo, go to the HAL repository from there, download it like before since I've already done it. So it downloads NEORV32, extracted it, and copied all of its contents to our setups file, setups folder. So the NEORV32 HAL folder already existed but it was empty, so just copy pasted everything there. Now inside here you first need to modify the alert toml file. So we are running our system at 12 megahertz, and this assumes 200 megahertz. So we'll just change it to 12 like this. Control S. Now so I am in the NEORV32 HAL folder. Dot ls. So you'll now go into the demos folder, which is so cd demos, just ALR clean in case there's nothing. Yeah. So first we'll run ALR build. So we'll build the ADA program. Build. First, then use the RISC-V 64 obj copy command. So we are going to create a bias.bin file. You can see in real time. So demos bin. You can see just this is, you know what, I'll create everything again just to show it. Yeah, love it. Executable, run RISC-V 64 bias.bin. Now we create an executable which is compatible with the NEORV32 using the ImageGen tool. Now ImageGen tool is provided along with the NEORV32. I have added it in my path. So yeah, now we have bias.exe. So going back to our GTK term window with the NEORV32, remember to set CRLF auto. So just press U to upload. It's main HAL demos bin exe. And let's run. Let's see. The demo works as expected. You can just say okay, system info. The main clock frequency is 12 megahertz. Run H, just available commands. E, I'll just say I know. Okay, something happened. Anyways, so this is getting the NEORV32 running on the Lattice ECP5 evaluation board along with an example ADA program. Thank you.